Welcome, one and all. This is Coach Jay, podcast section 7.1a, and I'm with you today. Hoping that maybe you don't even need this video because my wife would then still be pregnant in that way. But this video is hopefully to help those of you, if I am absent today, to be able to follow through with section 7.1a. Is that's what we're looking at, chapter 7. Just as a highlight for you, remember today we're looking at 7.1a. We'll look at 7.1b tomorrow, and finally wrapping up with section 7.2. We'll review the end of the week and then finally test on our final test, which is a partial test over chapter 7, noting we will skip over 7.3 and pick that up the second semester and really finish off with partial of chapter 7 there. So with that being said, because I always do, let's go ahead with the shot at the buzzer, and then we'll get into section 7.1a. Here we go. All right. Hey, by the way, this one's for you, Jaden. This one's for you. All right, here we go. Ready? Oh, so close. Let's go ahead. Let's get it going here. Hey, hope the last test was good. I'm doing this actually before it was actually graded. So I hope that hope we dominated it. If you have any questions, let me know. Remember, corrections should be due by today. For those of you who finished all the homeworks, if you did not, then unfortunately you won't be able to get those correction opportunities. However, if there was an issue or you ended up turning it in at some point, feel free to come and either text me, email me, or talk to me about that as we go. All right, let's see. All right, we are on. We are good. We are rearing and ready to go. All right, so let's start off with just a simple example and just kind of as we go through it. So we were going to ask, how did this chapter 6 test go? All right, we're going to take a sample from a population, and we'll talk about the differences between that. We'll use the average of the sample to estimate the average of the population. Now, let's pretend that Coach Jay has a very, very small 5th period class. I don't have a 5th period. But if I did, let's pretend that we have 4 different scores of 60, 70, 80, and 90. So what we're going to do is we're going to create a population distribution for by using a dot plot here. And what we'll do is, and it's pretty simple here because we have 60, 70, 80, 90. We'll just simply label 60, 70, 80, and 90. What should go underneath here would be the overall, just like a little label. Just, and I'll put this here for sake of room. But test scores on chapter 6 is fine. Okay, you just kind of put that there down below. Okay, so if I was to create this dot plot, we would have 60, 70, 80, and 90, right? And this would be the population because that's everyone that took the test in the context of just 5th period, right? Now, if we looked at all of AP statistics students on all of these chapters, that would be a little bit different, but there would be a dot on 60, 70, 80, and 90 that is there. All right, so question, I want you to pause this video and talk briefly about what that one dot means in the context of this problem, all right? Ready? Pause it and talk. And by the way, go to number 2 as well, all right? Pause me, and we're back, all right? Hopefully you paused me. Now we're back here. That one dot, real quick, I want you just to tell it out loud like I was here. Yes, I see you, Chris, yelling it out for tickets there. Nicely done. It would be one individual. I guess I could say Chris and mean 2 different people. So I meant both of you. How about that? One individual with a score of 90. Okay, that's one individual with a score of 90. It's going to be important that you understand that as we move forward. So next thing, take a sample of any 2 of the scores. So I don't know, 60 and 80. Okay, so I'm going to choose those 2. You might have chose something a little bit different. But you'll notice that in this context, the average of the two scores for me would be 70. Now, do I use mu of just mu, or do I use x? That's the question. Well, because it was a sample, I'm sorry, not x bar, my fault. Since it's a sample, we're going to use x bar, where mu is the population. X bar would end up being my sample mean, okay? So we take a sample, the two that I selected, not a very good sample because that was more, there's a lot of bias that was in there, right? I just picked two. But regardless, this was a sample mean that was created, and therefore we're going to use that x bar by stating that this is a sample mean. We'll talk about that more as we continue. Now, on number 3, go ahead and pause the video and see if you can come up with the different means of all the possible samples of size 2 from the population of the 4 students that's there, okay? So calculate a sample mean for each of these 2 samples. See if you can figure it out. And ready, go. Unpause me. And you could go ahead and unpause me if you've done that. If you're a little confused, you can just kind of listen in. The possibilities are 60 and 70, 60 and 80, 60 and 90, all right, and so on and so forth. We got 70 and 80, right? 70 and 90. We already had 60 and 70. So again, order doesn't matter here. So because I'm just randomly choosing to. And I think there's only one more of 80 and 90 that's created. So what we've got here is we've got means that are all over the place. We've got x bar equals 65. My mean of my sample here would equal 70. My x bar would equal 75. And I'm just going to keep my keep it flowing here. 5, 80, and 75. So based off this, let's make a dot plot using each of the means you found in number 3. Okay, so let's talk about this really quick. When we're doing this, each of these are various samples, right? And so what we have is a sample mean that we just conducted, right? So if I were to create this dot plot, this would then be samples of a sample. We talked about this. I will tell you what, if you could tell me, and be honest, because I'm not here with you right now, at least on this podcast, if you could actually figure out what activity we used that involved the sample of a sample, there's 2 of them, and you could text me that, I will give you, I'll give you 4 tickets, but you gotta text it to me before the end of the podcast, all right? So if you take out your phone right now, do it, and then put it away right at the end, okay? All right, so as you're thinking on that, what we're going to do here is we're going to create a distribution. So what we're going to have is 65, 70, 75, 80, 85, 90. So the context of this was samples, and that's going to be underneath, right? Samples of size 2. So mean of samples of size 2 for 5th period chapter 6 test, right? So that would be like the major context of what we just discussed. Now, as we look at this, we can recognize the fact that we have 65 and 70. 75, I think we had 2. We had an 80 and we had 85. So these were samples of a sample. Because it's a sample of a sample, what do we call this? We call this whole thing, this whole distribution, a sampling distribution. Remember we talked about this? I think you remember, and I'm going to show you the activity. Hopefully that will kind of jog your memory. By the way, here's a hint. It was from chapter, oh goodness, was that chapter 4, I think? When we talked about how to take a good sample, it was chapter 4. Okay, so question, what does this 1 dot mean? Go ahead and pause me, discuss it, see if you could figure that out. And now unpause me. This is not one sample. This is actually I'm sorry, this is not one test score. This is one sample of size 2 and with a mean of 65, right? So each of these dots represents the average of 2 various test scores, right? And we kind of put that over here with the context on that side because it's a sample of a sample. We have that as a sampling distribution where each of these values, right, this 65 would be X bar is equal to 65, okay? Now, coming back to this, a sampling distribution always has a center around where the true mu is. Well, what is the true mu? This is the population mean. Well, how do I find the population mean, Coach? We'll come back here for just a second. You could find that by just finding what the mean is of all of the values in my population. Now, sometimes that's impossible to find, and that's why we estimate using a sampling distribution, and that's really where we're going to go from chapter 7 all the way through to the rest of the year. So right now, this is kind of a big deal on how we're approaching this as we go to Turner and as we utilize this to answer questions later on. So the average of those 4 test scores produces a true mu of 75 if we average those 4 test scores together. But if you notice, where is 75? Well, the 75 true mu actually falls on the center of my sampling distribution. So what's cool about this is we can see that in this instance, the samples of the sample actually aligns and has the same center as my true mu mean. All right, so coming back here, I think I did that on number 5. What is the mean of the population? We just did that on the one that was previous to this, and we found that mu was actually equal to 75, and we found out that the sampling distribution center fell on the true mu, and that would be the case here. All right, so as we keep going towards the check your understanding and that sort of thing, let's talk about some important ideas. The ideas that we're going to discuss today are extremely important in kind of the overall theme of where we're going to head. So let's talk about a sampling distribution. All right, this is very important, the difference between sampling and sample distribution, okay? A sample distribution, which we did not talk about today, is a distribution, maybe a dot plot or a histogram or whatever, but it's the distribution of the data in one sample. So the example of this would be if I were to take 20 different people from various AP stats classes and then putting each of their points on a distribution, that would be a sample distribution. Where a sampling distribution is much different. This is where it is showing all, and that's important, all the all possible samples, all the possible samples of size n. Remember on this previous one, what was n? N was, in our case, 2, right? So as we come over here, you'll notice this was of size 2. But as we looked up here, each of these X bars of size 2, it's all the possible samples of size 2. And then we plot that, okay? So as we look at this, if I were to kind of draw this out, and that was just to put dots on, right? We have context and all that. I'm just putting this out. If I were to have this one dot, and I just made it bigger just so you could see it, this is a dot that corresponds to one statistic of size n. We'll talk about what a statistic is in a second. But one statistic, one sample of size n, and it's the average of that specific, the average or the proportion that corresponds to whatever the sample size would be there, okay? Notice this, remember a population distribution the difference between a sample distribution and population. A sample takes only a select group of people. Each dot on, here, let me do this. Let me kind of just show you this to you. Over here, if I had dots here, this dot corresponds to one person's test score, right? Where up here, this corresponds to the average of 3. I'm using 3, but it could be 2 was the other one. The average of the size of the samples that I'm taking, size 2, 3, whatever it may be. But down here, this is one person's test score as a sample distribution. Population would be if we took this sample and we had all individuals graphed in the distribution, okay? Graphed in the distribution. That would be the difference between a population, sample, and sampling distribution that's there. Okay, so let's talk about this. What is a statistic and what's a parameter? And then I'm going to have you do to check your understanding there, okay? Statistic and a parameter by definition. These are just different words, but we've said it before. A statistic is a number that describes a sample. Number that describes a sample, okay? So when I come up here and I'm looking at this here, this is a statistic because this one dot is one statistic or one sample of size n. Okay, we'll come back to that. A parameter describes a number in the population. Number that describes population. I like this because when we look at, and again, it's the value, right? So when we think of parameter and we think of statistic, X bar is a number that describes the sample, whereas mu is a number, or the mean, that describes the population. Therefore, it's a parameter. So P and P, population, get this here, P and P, population, parameter, S and S, statistic and sample. So here's the difference between them when we describe it, and it's very important that if you're going to use notation, that you use the correct notation, otherwise you will get counted off, okay? So this is a proportion, right? This is mean. S is standard deviation, and here we go. So when we take a sample or statistic, a statistic is a number that is a part of my sample, right? X bar is an example. A statistic estimates a parameter. A lot of times we don't know what the actual population is, so we use a statistic to be able to estimate a specific parameter that's there. I use X bar, the mean of my sample, to estimate my true mean of mu, because sometimes I don't know. Population's too big. Sometimes I use P hat. P hat is, again, the proportion of my sample that describes or estimates my true P, my true proportion of the context of the problem that I'm in. S is the standard deviation, estimates my true mu, my true standard deviation of my population. So over here on this side is the population, where these are the samples. Okay, so these describe a sample, these describe a population. Each of these values we call a statistic, and these are parameters. Okay, so parameters are numbers that describe population. Statistics are numbers that describe samples. Okay, I hope that made sense to you here. Go ahead and pause this video. Check this out. See if you can kind of explain this. This is really good as we move forward on this. Pause it, and when you're ready, unpause it and go ahead and double check and make sure that you in fact got this correct within the problem up above. Okay. So as we look at this, hopefully this makes some sense here, and you can even turn this video off as you finish up. But maybe you had some questions on this. Here's a claim. So 200 chips are in the bag. That's the population, right? And that 100 of them are red. Well, if 100 of them are red, then my proportion, right, when we talk about proportion or parameter, would be P is equal to 0.5 because that's describing when Jenna selected, that's like the sample, right, of the 200 of 20 chips, 20 being my sample that I selected, right? The statistic, she got 7 reds, 7 out of 20 represents my P hat. So we're using P hat to estimate my parameter, my statistic to represent my parameter, P hat to estimate P. So what is evidence that less than half of the chips in the bag are red? Well, within our sample, we got a proportion of P hat equals 0.35. Therefore, this is less than 50% or 0.5. Therefore, this would be evidence to prove that. Provide 2 examples or explanations for the evidence described in part A. Yeah, this is kind of from our statistical significance. We got 7 out of 20 purely by chance. And then B, kind of going back to, or number 2, going back to the previous part, and number 2 up above, is there were less than 50% in the red bag. All right, we have, in this case, we use technology to simulate choosing 500 simple random samples, right? Which, by the way, that means that this is a sampling distribution, just a heads up, right? So sample of a sample, SRS, a simple random sample, 500 of them. So each dot represents one SRS of size 20, right? So each of these are of size 20, each dot. From a population of 200 chips, 100 are red and 100 are blue. The dot plot shows P hat as the sample proportion of red chips for each of the 500 samples. So we would expect, if this is true, that the majority of them would fall underneath 0.5, right? But then it says there's one dot on the graph at 0.8. Explain what this value means. Well, this dot represents that out of a size 20, the P hat of this would equal 0.8. So meaning 80% of the 20 chips that I selected would equal 0.8, right? So we're using this statistic of the proportion of P hat to estimate my true P, because I know because they say it, but sometimes we don't know, therefore we use this to estimate here. And as you can see, that's what we stated in number 4. Number 5, would it be surprising to get a sample proportion of 0.35 or smaller in an SRS of size 20? Well, 0.35 would be here, even though there are not a ton of data points here, because like there are a number of them. There's not so little. It's not less than 0.05. Like it happened often enough for us to not say that it's surprising, right? So what does surprising mean? That means less than, like whatever we're trying to find is less than or equal to 0.05 to be surprising or statistically significant. That could have happened purely by chance. Number 6, based on your previous answer, is there convincing evidence that less than half of the chips in the large bag are red? This comes back to our that activity, and that would be no. Yeah, there's not a large enough chance that we get a sample, and this is where we state that it could have happened purely by chance there. Now, as I wrap this up, let's see if you can think about what activity represented a sampling distribution that's here. Well, when we look at this, let me see if I can find it. Remember this one? If you said Justin Timberlake's sample of a sample, remember we talked about finding a good sample between stratified and cluster. I don't know if we did cluster on this one, stratified or an SRS. We took a simple random sample. Each dot represented a specific sample that we took, and then we averaged that together and went from there. We talked about enjoyment level at his concert. I don't know if you remember that. There was that one. And then finally, some of you remember maybe my favorite activity here. See if I can find it. Is it here? Is it here? Oh, yeah, yes. Okay. some of you remember this one, which is the Beyonce activity, which, if you remember right, we talked about how do you sample. We took 5 words within her song, Crazy in Love, to just kind of compare what we said the average, the X bar of each sample that was selected, right, was like an average, I think we'll say 10 words. So we averaged the word length of 10 random words. And based on those random words, each dot that we have here, like this dot, represents the average of 10 words, right? And we had a ton of samples. So this is a sample of a sample, right? And because of that, we then use this to estimate my true mu, the true average word length for the entire song. And we found out that we had what we call a statistic, which would be the mean of 10 words. And we use that to estimate my true mu, which is the mean of all words. We call that a parameter. Okay, I hope that makes sense. That's what we're looking at within this. And that would be the first section, 7.1a. Have a great day, y'all. See you, peeps.